Alright, so the longest professional tennis match ever played lasted a total of 11 hours and 5 minutes. How many minutes is this? So if we know that there are 60 minutes in 1 hour, right? Then there's 11 hours. You're going to have to do 60 multiplied by 11 is equal to 660. Then you have to add this extra 5 minutes, so 660 plus 5 is equal to 665, which is equal to C. Alright, in rectangle ABCD, AB is equal to 6 and AD is equal to 8. Point M is the midpoint of AD. What is the area of AMC? In this video, I'll be showing two ways to solve this problem. So first off, we could do the way you probably think of first. Base times height, so this is 4 multiplied by the height, which is 6, and divide that by 2. That is equal to 24 over 2 equals to 12. So we know the answer is A, but I'm going to give an alternative solution. Since this is the midpoint and this is 4, we know this whole area is 8. So you can do 8 times 6 to get 48. And we can subtract the area of these two triangles to find this one, because that might be a little easier. So since we know this is 8, this is half of 48, because it's 6 times 8 over 2, which is equal to 24. So it could be 48 minus 24 plus, and we see that this is 4, this is 6, so that's 12, because 6 times 4 over 2 is 12. So then we get 48 minus 36, which also gives us an answer of 12. So there you go. 4 students are taking an exam. 3 of their scores are 70, 80, and 90. If the average of their 4 scores is 70, then what is the remaining score? Now, what do we know? We know that average is equal to the sum divided by the number of numbers. Now, what do I mean by that? That means that the average is equal to the sum of all of the numbers divided by the amount of numbers. For example, if we have 1 and 3, the sum of them is 4, and the number of numbers is 2. So 4 over 2 is equal to 2. That's the average. Okay? So we can actually plug that in here. If we know that the average is 70, that means 70, we can set up an equation like this. 70 is equal to the sum, which is 70 plus 80 plus 90, plus a mystery number. We don't know the fourth score, right? So 70 plus 80 plus 90 is 240. So 240 plus, make a variable x. And we're dividing that by the amount of numbers, which is 4. Right? So in this equation, we multiply both sides by 4 to cancel this out. So we get 280 is equal to 240 plus x. You probably see where this is going, but if you subtract 240 from both sides, you get x is equal to 40, which is A. When Chinu was a boy, he could run 15 miles in 3 hours and 30 minutes. As an old man, he can now walk 10 miles in 4 hours. How many minutes longer does it take him to walk a mile now compared to when he was a boy? So for this, we just need to find the unit rate for 1 mile. So 3 hours and 30 minutes is equal to 60 times 3 plus 30, which is 180 plus 30, which is going to be equal to 210 minutes. Okay? So if he has 210 minutes, and 15 miles, and we're trying to figure out how many, like in 1 mile, I like to visualize it like this, in a ratio of miles to minutes. So 210 minutes is equal to 15 miles. So 1, we're actually dividing this by 15. And we're going to also divide 210 by 15. Remember, don't divide 15 by 210. We're doing 210 divided by 15. So when we do that, we can get 14. Right? So, because 14 times 15 is also 210. So let's write that down. When he was a boy, 14 minutes. Okay, now that he's an old man, 10 miles in 4 hours. So we're going to do 10, and then 4 times 60 is 240. That is going to be equal to, this is 2, then we get 40, 24. So when he was old, it was, 24 minutes. So therefore, it's asking how many minutes longer. So it's 24 minus 14 is going to be equal to 10. Okay, so the answer is B, 10 minutes. Alright, let's get started with this problem. The number n is a 2-digit number. When n is divided by 9, the remainder is 1, and when n is divided by 10, the remainder is 3. What is the remainder when n is divided by 11? So, what we can do, I think the second bullet point is a better starting place, because anything divided by 10, it's going to be a better number, right? So, 10 divided by 10 is 1. To find something with the remainder of 3, we just have to add 3 to that. So 13 divided by 10 is going to give us 1, the remainder of 3. And it doesn't matter what the first digit is. It could be 2, 3, 4, doesn't matter. It's always going to have a remainder of 3 if the second digit is 3, right? So, this is 3. When it is divided by 9, the remainder is 1. So, 9 divided by 9 is 1. So to find the remainder of 1, we just have to do 10 divided by 9, which will give us 1 with the remainder of 1. Now, we can also see that there's a pattern. 9 divided by 19. It's going to be 2 with the remainder of 1. All we have to do is add 9 each time, right? So we find a number that is with 9 and then just add 1. So 9, for example, we could do 9 times, we need to find a number that is 1 less than 3. Does that make sense? So it's going to have 2 as its ending digit. So we can actually multiply it by 8. That's the only one. We get 72. So that's a good starting place, right? So that means that if we do 9 over 73, if we add 1 to that, we can just do 8 minus 72, and we have a remainder of 1. Therefore, first digit is 7, and the answer is 73, but that's not what the question is asking. It's asking the remainder when n is divided by 11. So we can just write that out. 73 and divided that by 11. We're going to get 6 minus 66. It's going to give us 7 for this part, right? So we have a remainder of 7, which is E. Okay, so my solution to this problem is going to be a little bit different than most people's, and it's going to be more visual. And I just wanted to give that so you have an alternative solution. So the following bar graph represents the length and letters of the names of 19 people. What is the median length of these names? So they give us a bar graph and we're trying to find the median. Well, we know that the median is going to be the number in the middle. So what we can do is just start crossing off bar graphs. So we see this is actually 4, frequency of 4. So let's cross 4. I'm going to use white so it's easier to see. Cross 4 out. And then on this bar graph, we can take 4 out of it, right? Take 4 out of it. So it's all about making it even and making sure that we do it right. So this is going to be 1, 2, and 3, right? So cross the 3 out, and cross the 3 out of here. Then we have this 1 we can take from here. And then this one we take from here. And we get this one, which is 4. So therefore, our answer is 4. Which of the following numbers is not a perfect square? So let's try to figure out, how do we know if it's not a perfect square, right? So let's say we have 2 squared. That's equal to 4. That is a perfect square. How about 2 to the power of 4? That is going to be equal to 16. That is a perfect square. What about 2 to the power of 6? That's going to be equal to 256. So you're noticing a pattern. These even exponents are all making it perfect squares, because these are all perfect squares. And how do we know that? It's because the difference is by 2 numbers, so it's basically just squaring this number. So 4 squared 16, 16 squared 256. But if we did like 2 to the power of 3, for example, that gives us 8, not a perfect square. If we do 2 to the power of 5, that's going to be equal to 32, not a perfect square. Therefore, we can try to find the numbers that have odd exponents. Okay? So this is even, can't be that one. Even, even. So now we're stuck between B and D, and they're both odd exponents. But it's B because 4 is a perfect square, so it's not going to work. It's still going to be a perfect square. So it's going to be, find the value of the expression 100 minus 98 plus 96 minus 94, and so on. So this problem is all about recognizing patterns and recognizing the commutative property of addition. Now you're probably wondering what that is. Let me show you. For example, -1 plus 8 and 8 plus -1 are both equal to the same thing. They're both equal to 7. So that shows that it doesn't really matter what the order is. But don't think that you can do 8 minus 1 and 1 minus 8, because those are two different things. Because for this one, you're actually just doing 1 plus -8. And for this one, you're saying 8 plus -1, which are two different things. You're saying that this is negative and this is negative. But that's not true. If you need to write it like this, where the negative sign is consistent on both terms. Okay? So now that we know that, we can put these into groups. I'm not going to do all of them, of course, but and we notice that since they're skipping by 2, there's no 99 or 97. There's 50 numbers total, because 100 numbers divided by 2. And then the amount of groups, since there's 2 in each group, 50 divided by 2 is 25. So we have 25 groups. If each group is equal to 2, as you can see, 2, 2, 2, we can just multiply 25 by 2. And we will get 50. And that is our answer, C, 50. What is the sum of the distinct prime integer divisors of 2016? So the best way is to try to find some simple divisors. 2016 is equal to 2 and 1008. 1008 can be broken into 2 and 504. 504 can be broken into 2 and I think, let's see. If you do 504 divided by 2, you get 252. Break that up into 2. We get 2 and 126. Break that into 2. You get 2 and 63. Now we can't divide this by 2, but we can find other numbers. So we could do 9 and 7, right? 7 times 9, 63. And then, 9 could be turned into 3 and 3. So let's look at the prime ones. We have 2 here. Let's see. We have 3 here and 7 here. These are all the prime factors of it. And it's asking us for the sum of them. And if you're curious, it's 2016 is equal to 2 to the power of 5 multiplied by 3 to the power of 2 times 7. We know that because there's 5 2's, 2 3's, and 1 7. But when we add 2, 3, and 7, we get 12, which is B. Suppose that A star B means 3A minus B. What is the value of X if 2 star parentheses 5 star X in parentheses is equal to 1? So we start in the parentheses. A is equal to 5 in this case. So if it be 2, and I'm going to use a dot so it's easier to draw for the star. And then parentheses 3 times 5 is 15. Minus B is X, so minus X. Then we have to do 3A for this, so we get 6 minus 15. And you may think minus X, but that's not actually what you would do. You would do plus X because of 2 negatives we can make a positive. So you get that's equal to 1. 6 minus 15 is equal to negative 9 plus X equals 1. Then you add 9 to both sides to get X is equal to 10. So that is our answer, D. Determine how many two-digit numbers satisfy the following property. When the number is added to the number obtained by reversing its digits, the sum is 132. So let's break this question down. It says when it's added to the number obtained by reversing the digits. So that would be like an example, 13 plus 31. You're going to get 44. That's not 132, but that's just showing you what it means. 13 plus its opposite digits. So we can actually make variables. So this can be A and this can be B. Remember the sum of them plus its reverse is 132. So if it's in the tens place, that actually means 10 times whatever this number is, right? So we can make an equation out of this that 10A, I'm going to use a capital A so it's consistent, 10A plus B plus 10B plus A is equal to 132. Why? It's because this is like this number and we're adding it to its opposite, so we have to make 10 times B when it's in the tens place, right? And A is just a single number. So we can add all these up. So we can get 10A plus A, so it's 11A plus B plus 10B is 11B. And that's equal to 132. So we divide both sides by 11, which means we cancel all these out. So we get A plus B is equal to 12. right? So now that we know that, we can just keep trying numbers and see if we can find them all. So if we have 1, that's not going to work, right? 1's not going to work because no number plus 1 can be equal to 12. So same as with 2, but you can get something with 3. What is it? It's 9, right? 39 is going to be equal to 12 because 39 plus 93 is equal to 132, which meets our qualifications. Let's try the next number. How about something with a 4? It's actually going to be 48. See a pattern? We add 1 to the 10th digit, subtract 1 from the ones digit. Okay? So now we have 57, 66. And we're not going to have to do 2 of these later because it's the same number. You'll see what I mean later on. And then we're going 70 and then 5, which is actually the inverse of this number, if you notice. So what do you think the next number is going to be? It's going to be the inverse of this number, which is 84. That's why I'm saying we won't have 2 of these, because it's just switching the numbers, right? And then finally, we have 93. Now, if you go back to what the question's asking us, it's asking us how many numbers. So if we count them all, we have 1, 2, 3, 4, 5, 6, 7 numbers. So the answer is B, which is 7. Jefferson Middle School has the same number of boys and girls. 3/4 of the girls and 2/3 of the boys went on the field trip. What fraction of the students on the field trip were girls? So the first thing I did to solve this problem was see that 3/4 and 2/3, you can change them into 12ths so that they have equal denominators. So this is going to be 8/12 and this is going to be 9/12. And I'm going to label this as G for girls and 8/12 is B for boys. So let's just assume that there's 12 of each, right? 12 boys and 12 girls. Well, that means that 8 boys on the trip, and that means that there were 9 girls on the trip. So what fraction of the students on the field trip? Not in total. We would actually add both of these up. So we can make a fraction out of this. The total amount of people is 17, and the amount of girls is 9. So therefore we get 9 out of 17, which is going to be letter B. 2 different numbers are randomly selected from the set -2, -1, 0, 3, 4, and 5, and they're multiplied together. What is the probability that the product is 0? So for the product to be 0, one of the 2 numbers has to be 0. So for the first number to be 0, the probability is 1/6, because there's one probable outcome, which is 0, and 6 total outcomes. And since they're doing 2 different numbers, we can multiply that by 2 to get 2/6, which is equal to 1/3, which is D. Carl's car uses a gallon of gas every 35 miles, and his gas tank holds 14 gallons when it is completely full. One day, Carl started with a full tank of gas, drove 350 miles, bought 8 gallons of gas, and continued driving to his destination. When he arrived, his gas tank was half full. How many miles did Carl drive that day? So, let's write this out. 1 gallon of gas is 35 miles. So we can write that as a ratio, gallons to miles is equal to 1 to 35. And then his gas tank holds 14 gallons when it's full, and he started on that. So he drove 350 miles plus something else, so it's going to come later in the question. It says he bought 8 gallons of gas, continued to drive to his destination, and when he arrived, his gas tank was half full. So when he arrived, his gas tank was half of 14, which is going to be 7. Okay? So after he started with the full tank of gas, he drove 350 miles, right? So if he did do 350 miles, that means he used 10 gallons of his gas. If it was full, it was 14 minus those 10 gallons to get 4 gallons left. Then he bought 8 gallons, so it'd be 8 plus 4 gallons, which is 12. And he continued to drive. So it says when he got there, his gas tank was half full, which is 7. So if it was 7, it would be 12 minus 7, which is 5. So therefore, if he used, that means he used 5 gallons of gas after this 350 miles. So if we do, this is 5, we're multiplying 35 times 5, which is 175. So when we add 175 plus 350, we get 525 miles, which is letter A. What is the largest power of 2? That is a divisor of 13 to the power of 4 minus 11 to the power of 4. So for this problem, I'm going to write out the problem. That can be changed into 13 to the power of 2 plus 11 to the power of 2 times 13 to the power of 2 minus 11 to the power of 2. And now we use the difference of 2 squares formula for this. We get 13 squared plus 11 squared. And for this, we can change that into 13 minus 11 and then 13 plus 11. When we do that, we will get 13 squared plus 11 squared, and then that's 2, then that's 24, right? So from this, we can figure out that this is 169 plus 121, which is 290. So we get 290 multiplied by 2 multiplied by 24. And for us to figure out the largest power of 2, it's what it means by power of 2 is like 2 to the power of something, not something to the power of 2, okay? Just to elaborate. So this 290 is equal to, let's see, we can actually put this into two things. 2, and if you do 290 divided by 2, we get 145. Then 2 and 24. Okay, so with 145, with 24, we can put this into two things. 8 and 3. So our numbers are 2 times 145 times 2 times 8 times 3. Just to elaborate on why we're doing this is to see only the ones that are divisible by 2. So we can group them into two groups. The ones 2 times 8 times 2, which are divisible by 2, and 145 and 3, which are not divisible by 2. So we're not actually worried about 145 times 3. We can just ignore it. But when we multiply these three numbers, we get 16 times 2 equal to 32. And that is actually our answer, because 2 to the power of I believe 5. Yeah, 2 to the power of 5 is equal to 32. And that is the greatest power of 2. That's a divisor of 13 to the power 4 minus 11 to the power 4. So we get C, 32. Annie and Bonnie are running laps around a 400-meter oval track. They started together, but Annie is pulled ahead because she runs 25% faster than Bonnie. How many laps will Annie have run when she first passes Bonnie? So, if Annie is faster than Bonnie, we can do a ratio of A to B, Annie to Bonnie, and Annie can run, let's just say Bonnie runs 1 lap. 25% of 1 lap is 0.25, and it's faster, so it's 1.25. So, for every 1 lap that Bonnie runs, Annie runs 1.25. So, when she first passes Bonnie, they both have to be like a whole number for that to work. So, let's just say for this to be a whole number, we have to multiply it by 4. So we would get 5. And multiply this by 4, we get 4. So if Bonnie runs 4 laps, Annie runs 5 laps. So when she first passes Bonnie, Annie will have run 5 laps. So the answer is D. An ATM password at Fred's bank is composed of 4 digits from 0 through 9, with repeated digits allowable. If no password may begin with the sequence 911, then how many passwords are possible? So don't confuse 4 digits with a 4-digit number, because a common mistake is people think the first digit can't be 0, because that wouldn't be a 4-digit number, but that's not true. It just says it has 4 digits, okay? So the best way to solve this problem is to find the total amount of 4-digit numbers, and then from there you can subtract the amount of passwords that begins with 911. So if it can, let's write out like this. The first digit has 10 different numbers you can choose from, 0 through 9, right? The second digit also has 10 digits, and so on. So it's going to be equal to the total amount of possible combinations are 1, 0, which is 10,000, right? Because it's 100 times 100. So we can do some simple subtraction from this. If the digits begin with 911, then this digit still has 10 choices, right? So we can just subtract those 10 choices from here, and we get 9,990. And that is our answer, D. In an all-area track meet, 216 sprinters enter a 100-meter dash competition. The track has 6 lanes, so only 6 sprinters can compete at a time. At the end of each race, the 5 non-winners are eliminated, and the winner will compete again in a later race. How many races are needed to determine the champion sprinter? Okay, so we can make an equation for this problem. 216 total sprinters. And we can subtract, since there's 5 non-winners that are going to be eliminated, we multiply that by the amount of rounds, which we can call X. And that's going to give us 1, which is going to be the champion, right? There's 1 person left over. And that means that we can solve this equation to get, you can subtract 216 from both sides. You get negative 5x is going to be equal to negative 215. So divide both sides by negative 5. Therefore, x is going to be equal to 43. So C is our answer, 43. The sum of 25 consecutive even integers is 10,000. What is the largest of these 25 consecutive integers? So for this problem, I'm going to show a different way to solve it. Since we know that the sum is 10,000 and there's 25 numbers, we can actually use the mean or average formula for it. So average is going to be equal to the sum of all the numbers divided by number of numbers. Okay? Sorry for my handwriting. So if we already know what the sum is and what the number of numbers is, we can just use this formula. So we get 10,000 divided by 25, which is equal to, I think it's 400, right? Because 400 times 25. And then from 400, we know that's the middle number. How do we know that? Because the average is going to be kind of like the median where it's in the middle. So I'm going to point out that it says even, right? And since this number is in the middle, it's the 13th number, right? So that means there's 12 numbers more to go. And you might think 412 would be the answer. That's not true. Because since it's even, we have to do 12 more numbers and multiply it by 2 because it's skipping a number. So we get 24. So 400 plus 24 is equal to 424, which is letter E. The least common multiple of A and B is 12, and the least common multiple of B and C is 15. What is the least possible value of the least common multiple of A and C? So it's easier for me if I write it out. So A and B, and I'm just going to put an equal sign to 12. And we have B and C is equal to 15. So they both have a common factor, right? It's B. They both share B. So B times A is 12 and B times C is 15. So we have to find the greatest common factor between these two numbers to find out what B is, right? So, and we know this is going to be the greatest common factor because this is the least common multiple of these two numbers, right? So we can write out the factors, so 15. So we have 1, 3, 5, and 15. And we can write out the factors of 12. We have 1, 2, 3, 4, 6, and 12. So the greatest one that they have in common is 3, as you can see. So therefore, B is going to be 3, right? So if the least common multiple of 3 and another number is 12, the other number is going to be 4, right? Because 4 times 3 is 12, and also all the other numbers don't work because 3 is going to be, it's going to be 3, and then 2, you see, it's not going to work like that. So 4, there's at least one. And then for C, we have 5 because all the numbers below it don't work. So we have 4 and 5, and it's asking for the least common multiple of them. So we're looking for the LCM of 4 and 5. So we can write out the multiples, multiples of 4 first. 16, 20. And I can stop at 20 because I know that 5 times 4 is 20. So if there's nothing below it, it's going to be 20. So we can do 5, 10, 15, and 20. We see that they both have 20 in common. So we know that our answer is going to be 20, which is A. A top hat contains 3 red chips and 2 green chips. Chips are drawn randomly one at a time without replacement until all 3 of the reds are drawn or until both green chips are drawn. What is the probability that the 3 reds are drawn? So for this problem, we can do one draw at a time. So the chance that the first draw has a red chip is 3 out of 5 because there's 3 red chips out of 5 total chips. Next, since we removed 1 red chip, there's 2 left. And also, we have to subtract the total by 1. So we have 2/4. And we're also going to multiply that by 1/3 because we're subtracting 1 red chip and 1 from the total. So here we're going to get 6/60, which is equivalent to 1/10. But that is not our answer because there's 4 turns where you can pick the red chip because the last turn can't be red, right? So we multiply this by 4 to get 4/10, which is equal to 2/5. And that is our answer. Rectangle DEFA below is a 3x4 rectangle with DC is equal to CB, which is equal to BA, which is equal to 1. The area of the bat wings, the shaded area, is blank. So it says this is 3. So the best way to solve this is to find the area of the entire thing and subtract these triangles that are white to find the area of the black bat wings. So we can do 12 minus, and we have to find this. We know this is 4, so the area of this is 2, and so is this, right? These two are both 2. So what we do know, we can split this in half. It's helpful. So we can do 2 plus 2 plus. And to find the area of this, it's an equilateral triangle, right? So we think since this is an equilateral triangle, 1, 1, 1, they're all equal. So that means that the height is also equal to 1. So 1 times 1 divided by 2 is 0.5. So that's the area of that. And then for this triangle, since this is 1 and this whole area is 4, we can tell that this height is 3. So 3 times 3 is 9. And that's 9/2 is equal to 4.5. That 2 looks like a Z. Anyway, when we solve this, we get 12 minus, this is 4.5 times 2, because 4.5 plus 4.5, which is equal to 9. So we have 12 minus 9 is equal to 3. So therefore our answer is 3, which is letter C.
Hi everyone, today we're going to be looking over the 2016 AMC 8, specifically problem 23. This is a harder problem for me, but I found a method to solve it that's not like these methods. See, these look really complicated. Like, look, both of the radii of the same circle, all that. That's too complex. I'm going to explain it in an easier way so that you can understand an alternative solution for the problem. So, 2 congruent circles centered at points A and B each pass through the other circle's center. The line containing both A and B is extended to intersect the circles at points C and D. The circles intersect at 2 points, one of which is E. What is the degree measure of CED? One thing you also notice in this, they didn't draw it out. I think it's important to draw it out so that you can visualize. So, our choices are 90, 105, 120, 135, and 150. So, we're going to draw it out. I'm going to draw two circles because it says they're centered at points A and B. Since they pass through the other center, we can go ahead and draw one here. And draw one here. Make sure they're equal. we're going to start labeling. We can see that they're both centered at points A and B. So this is the center, the first one. And we know because it looks like the center, first of all. And second of all, the circle is passing through. So we can go ahead, I'm going to label it in red actually. This can be A, right? And this can be B. Now it says the line containing A and B is extended to intersect at C and D. So we can create a line out of this. I'm going to use black. But it says it's extended. So that means it can go on until here. It can go on until here. Right? So it says that it's intersecting at C and D. So we can go ahead and label that. This is C. This is D. Last thing to label, it says the circles intersect at 2 points, one of which is E. So let's look where they intersect. This is a point of intersection because both circles are touching each other at this point. So this can be E, and it says one of which is E. But really, it doesn't matter which one we choose. So I'm just going to label this one as E as well. Okay, let's get on with the problem. It's asking us to find the degree measure of CED. What does that mean? That means this. You know what? I'm going to actually use straight line just so it's a little better. CED. Okay. This is actually a triangle, as you can tell. But since this is also CED, we can label it. By the way, there's so many different ways to solve this problem. This is just how I would solve it, okay? So, we need to find the value of this angle. Oh, sorry. I'm going to go back here. The value of this angle. Now, one way that we can do this is by making an equilateral triangle. So, this is where my strategy differs from other strategies. Sorry, that was a bad line. Okay, so this is an equilateral triangle. How do we know that? It's because all the angles are 60, first off, and second off, all of these sides are equivalent. Now, that also means that this is also an equilateral triangle. So that is actually helpful because all the angles in a triangle add up to 180 degrees. Now, since there's 3 angles in a triangle, and this is an equilateral triangle where all the angles are equal, we can actually just divide it by 3. This gives us 60 for each angle, right? So this is 60, this is 60, and this is 60. And that's helpful because now we just need to know the value of this angle. You see, because we have part of this angle, but we also need to find this angle and this angle, which are from these triangles, right? So this is where you can see that a line is actually 180 degrees total, right? And since we know this is 60, we can do some simple subtraction. 180 minus 60, and you get 120. Therefore, we know that this angle is 120, so is this angle, right? Because these are equivalent triangles. This and this are both equal. So again, we know all angles in a triangle add up to 180. So what we can do is 180 minus 120 to get 60. This tells us what the sum of this angle and this angle is. So we know these two add up to 60, but we don't know what they are yet. But there's a way that we can now. See, circles can actually be turned into a bunch of equilateral triangles. So this specifically, it might be a lot to see right now. It might be pretty complex, but just stay with me. Okay, so we can actually make more. I'm going to use the green again. We can make more equilateral triangles. Okay. And we're not going to use all these in the problem. We're just going to, so you can see how they're all made up. All the green, it makes up this circle. If we wanted to, we can make up this circle as well. But we're going to stick with this one. So what you see is all of these angles are 60. You know that for sure. Right? But what we need to figure out is the angle of this triangle. I think it's kind of hard to see that now because of all the lines, so I'm going to outline it once more. I'm going to use U. Right? Again, we know this is 120, but there's something now that we know that we didn't know before. This side of the triangle and this side of the triangle are actually equal. We know that because all of these triangles, all of the sides are equal, right? And since this is actually just the side length of this triangle, right? And so is this. So these are equal. Now when we have two equal sides, it's an isosceles triangle, but it also means we have two equal angles. So now that we know that, since this is 120, we can do, we know that these add up to 60 and they're equal. So we can just do 60 divided by 2 to get 30, right? So now we know that this angle is 30, and also we know that these two triangles are equivalent, right? So this is also 30. So that means that this whole area is just the sum of these three angles. So you can do 30 plus 30 plus 60. That actually comes out to 120. Okay, that is our answer. Angle CED is equal to 120. So it's letter C. Thank you guys for watching this video. I hope it helped you if you were stuck on this problem and you want an alternative answer. Bye everyone.
The digits 1, 2, 3, 4, and 5 are each used once to write a 5-digit number PQRST. The 3-digit number PQR is divisible by 4, the 3-digit number QRS is divisible by 5, and the 3-digit number RST is divisible by 3. What is P? So, from this statement that QRS is divisible by 5, we can tell that S is either 5 or 0. We know that because all things of 5 are going to be ending in 5 or 0. For example, you have 10, 15, 20, 25. It's always 5 or 0, but 0 is not one of our digits, so it has to be 5. So if it helps, I can write out like this, PQR 5T. So we know that. And then next we can see that PQR is divisible by 4. So that means QR is either going to be equal to 12, 32, 24, or 52, because those are all the things of 4 using our numbers, right? So it could be 12, 32, 52, or 24. So if r is equal to 2, then that means that t has to be 2 or 5. But it can't, because those two options are both taken. So therefore, r must be equal to 4. So we can write this out, p, q, 4, 5, t. And specifically, q also has to be equal to 2 for that to work, because it's going to be 24. So p, 2, 4, 5, t. So from here, we can see that r plus s plus t is equal to 9 or 12. But since 4 plus 5 is 9, r plus s plus t must be equal to 12. So therefore, we know that t is equal to 3. Which means p has to be equal to 1, which is A. A semicircle is described in an isosceles triangle with base 16 and height 15, so that the diameter of the semicircle is contained in the base of the triangle as shown. What is the radius of the semicircle? So let's label everything. This is 16. Sorry for that. Oh, that's a really bad line. That's better. Height is 15. We can label these points. We can have A, B, and C. Okay? So the first step is to find the area of the entire triangle, which I will explain later, which is 15 times 16 over 2. That's going to give us 120. And we can make an equation to find the radius. But I'm going to label some more stuff first. So we can set this point as D and this point as E. DE is the radius of the circle, as you can see. So since it's the radius, it's also roughly equal to DA. So we can make an equation that 120 is equal to, so the area is equal to base times height over 2, normally. So what we can do is, since it's half of the triangle, we won't divide it by 2. We'll just keep it as it is. So we can do AC and multiply that by DE. But DE is equal to the radius. So we can just write AC times the radius. And that's what we're trying to find. So since we know that we have to figure out what AC is using the Pythagorean theorem, right? So since this is half, this side is equal to 8. So we know that 8 squared plus 15 squared is equal to x squared. So our answer for what the length of AC is going to be 17. Okay? Because it's 64 plus 15 squared is equal to 225. And when you add that to 64, you get 289, which is equal to 17 squared. So AC is equal to 17. Going back to this equation, we can see that 120 is equal to 17 times the radius. And we can divide both sides by 17 to isolate the variable. And with this equation, we get R is equal to 120 divided by 17, which is letter B.